The two ICH guidance documents, Q8 Pharmaceutical Development and Q9 Quality Risk Management, provide a science and risk-based approach to the development of pharmaceutical products. These two also represent a paradigm shift in the development, commercialization, transfer, and management throughout the product lifecycle. We consider this course as a seamless continuation of the introduction to system validation and qualification. So, if you haven't completed this previous course and understood the key concepts behind the validation and qualification process, we recommend you start there. Now, in this advanced course, we will discuss the system validation and qualification phases. Here, you will acquire a solid understanding of the science and risk-based approach to process validation, from information and knowledge in product development activities to defining a control strategy for the manufacturing process. Annex 15 of EU GMP states that qualification activities should cover all stages from initial development of the user requirement specification through to the end of use of the equipment, facility, utility, or system. For the qualification process, we can use the V model. There are others, but the V model is the most common. It is important to understand that this V model is based on risk assessment principles. It is an evolving process and needs to be updated from time to time. Changes in the project, facilities, and systems will require a re-evaluation of the risk assessment document. Let's review all of its stages independently. Phase 1 is placed at the start of the left side of the V model. The very first thing to define are the User Requirements Specifications, URS. This is a document that defines the specifications of equipment, facilities, utilities, or systems. The URS should define clearly and precisely what the end user wants or really needs. This is the point of reference used in the validation lifecycle. URS are written by the organization that is the owner of the system, facility, or equipment. Ideally, the emphasis of a URS is on the required functions and not the method of implementation. It focuses on the what rather than the how. When you write a URS, you are the end user's advocate. You need to make sure that all possibilities are considered and that you have included all requirements. Your goal is to write a comprehensive specification that is both detailed enough to serve as a development template and broad enough to include all desired functionality. So, the document should contain the user requirements related to documentation, environment, materials, safety, and maintenance. Here are our favorite tips and tricks to write a good URS document. Firstly, each requirement statement should be uniquely numbered and not longer than 250 words. The URS should be consistent and the requirement statements should not be duplicating or contradicting other requirements. Remember to specify requirements and not dictate a solution. The focus should be on what is required, but not how it is to be achieved. It is important to know that each requirement should be testable. This will allow the tests to be designed as soon as the URS is finalized. And finally, each requirement should be prioritized as mandatory, as per GXP requirements or desirable by the user. Note that mandatory requirements are the only ones that should be tested in the qualification phase. Otherwise, desirable requirements increase the good use or comfort of the user, but are not requirements from GXP regulations. A functional specification is a document that describes how a process or a system will operate. These functional specifications are written by the supplier after the URS are provided by the owner. It does not contain any highly technical detail. Rather, it describes how the system will operate according to the user requirement specifications. It also describes how people will interact with it and what to expect when different operational scenarios occur. Design specifications describe what the system, equipment, or facility should do and how it should do it, in line with the URS and the functional specifications. Design specifications are prepared by the supplier or implementer. There are two key moments to be faced before introducing a new equipment: a factory acceptance testing, FAT, and a site acceptance testing, SAT. The factory acceptance testing is usually performed by the manufacturer to verify the new equipment meets its intended purpose prior to approval for delivery to a customer. Once the equipment arrives at its final destination and is installed, a site acceptance testing is run by the purchasing organization as part of the commissioning activity. Thank you for attending this course. I hope you find it useful and that you have learned what you expected. See you in other courses at Scilife Academy to continue your learning journey.